Welcome to the Deep Dive Lab, where we break down and dissect cutting-edge scientific research. From advanced biomedical technologies to breakthroughs in AI, material science, chemistry, and physics.
Yeah.
And we tell it all as compelling, easy-to-follow stories.
Exactly. We try to keep it fun while really getting into the weeds of the science.
Right. And today, we are starting with a rather baffling piece of corporate history. So I want you to think back to 2008.
Oh boy, the Pepsi thing.
The Pepsi thing, yeah. So Pepsi decided to redesign their iconic logo, right? And they spent millions of dollars in the process.
Just an unbelievable amount of money.
Literally millions. And the redesign was accompanied by this 27-page internal design document. It was literally titled Breathtaking.
Which is quite a choice for a soda logo.
I mean, seriously. And this document linked their new red, white, and blue circle to the Earth's magnetic fields, the Mona Lisa, and this idea of an ultimate objective mathematical formula for beauty.
It really remains this sort of towering achievement in, marketing pseudoscience.
Right. It totally does.
Yeah.
But the crazy thing is, they aren't the only ones who lean into this stuff. Look at the Apple logo, or the Parthenon in ancient Greece, or even the Great Pyramids.
Right, you hear those examples all the time.
Constantly. We're always told that these structures share this singular governing principle, which is the golden ratio, or phi.
Which is roughly 1.618 for anyone doing the math at home.
Right, 1.618. And we actually have a really fascinating stack of research in front of us today provided by a listener. It ranges from the 1854 historical writings of a German psychologist all the way to a 2024 cognitive study published in the journal Symmetry.
Yeah, and we even have some papers from physical laboratories modeling how plants grow. It's a really wild mix of sources.
It is. So our mission for this deep dive is to figure out if there really is a universal mathematical formula for beauty hardwired into the universe, or if we've all just fallen for this elaborate 150-year-old illusion. Okay, let's unpack this.
Well, to unpack this, we really need to briefly ground ourselves in what the math actually represents. Because the reality of the golden ratio is it's completely detached from the myth we've all been sold.
So where does it actually start?
At its core, it's just a geometric proportion. It was first recorded by the Greek mathematician Euclid way back around 300 BC.
Okay, so a very long time ago.
Right,
Yeah.
and he termed it the extreme and mean ratio. Basically, if you take a line and divide it into two parts, you do it so that the ratio of the whole line to the longer segment is exactly identical to the ratio of the longer segment to the shorter one.
So it's basically just an elegant geometric puzzle.
Exactly. It's a math puzzle. You run the numbers, and it produces this irrational number that just stretches out infinitely.
Like pi.
Right, like pi. But for convenience, we just round it off to 1.618.
But wait, Euclid was using this to calculate things like the areas of pentagrams and platonic solids, right?
Yeah.
He wasn't sitting there applying it to, human aesthetics or art?
Not at all. I mean, the whole aesthetic myth-making thing didn't truly begin until the Renaissance. Ah, okay. The Renaissance.
Yeah. In 1509, there was this Franciscan friar named Luca Pacioli, and he published a book called Divina Proportione.
The divine proportion.
Exactly. And crucially, it was illustrated by Leonardo da Vinci.
Oh, wow. Okay, so that's a heavy hitter right there.
It is. And that collaboration really planted a seed. By the time we reach the late 16th century, you have the astronomer Johannes Kepler referring to this ratio as a precious jewel.
So it just kind of snowballs from there.
It really does. Over the centuries, that enthusiasm compounded. It morphed into this widespread belief that this exact ratio intentionally governed the Great Pyramids, the facade of the Parthenon, and, even the ideal proportions of the human face.
Well, here's where I kind of have to push back on the historical narrative. Because when you actually look at the Parthenon, or if you take one of those so-called golden rectangles and overlay it onto the Mona Lisa, the math simply doesn't hold up under any real scrutiny.
Oh, it falls apart completely.
Yeah. Mathematicians like George Markowski at the University of Maine, they've actually done the rigorous work of measuring these structures.
And what did they find?
Well, they found that the proponents of the golden ratio are basically heavily doctoring their homework.
That's hilarious.
It's true. If you look closely at the diagrams that superimpose the ratio over the Parthenon, the lines they draw on the image are incredibly thick.
Like thick marker lines.
Exactly. They are drawn that way to intentionally hide massive margins of error in the actual math.
And the starting points are completely arbitrary, too.
Yeah.
I mean, depending on which diagram you look at, they might measure the Parthenon from the bottom step or, the second step of the edge of the roof.
Just to fudge the numbers until they get something close to 1.6.
Right. It honestly reminds me of lying in the grass and looking at clouds.
Yeah.
If you stare at the sky long enough, your brain will eventually piece together like a bunny or a pirate ship.
Exactly. But it doesn't mean the water vapor is actually shaped like a ship.
No, of course not. Our brains are simply desperate to find recognizable patterns in all that chaos.
And this raises an important question because that cognitive vulnerability is exactly what allowed this myth to basically hijack human psychology.
So who actually started it then, if it wasn't Euclid and it was only kind of vaguely started in the Renaissance?
Right. If Euclid and Pacioli weren't the ones aggressively pushing it as this absolute aesthetic law, we really have to look at who actually pointed at the clouds and told the rest of us to see the dragon.
Who was it?
The modern culprit is a 19th century German psychologist named Adolf Zeising.
Adolf Zeising, okay.
Yeah. In 1854, Zeising published this sprawling thesis claiming the golden ratio was a universal orthogenetic law of nature and art.
I mean, that era of the 19th century was notorious for that kind of rigid thinking. It's the exact same intellectual environment that gave us phrenology.
Oh, right. The skull bumps.
Yeah. The idea that you could determine a person's intelligence or like their criminal tendencies just by measuring the bumps on their head, they were just totally obsessed with turning human subjectivity into hard, quantifiable data.
And Zeising applied that exact mindset. He forcefully mapped the golden ratio onto the human body by making completely arbitrary measurements.
What kind of measurements?
Well, his primary piece of evidence was that if you measure the distance from a person's navel to their toes and then divide that by their total height, you magically arrive at the golden ratio.
Which is so meaningless. I mean, the human body has thousands of distinct points of articulation.
Right.
If I measure the distance from like my collarbone to my kneecap or my elbow to my earlobe, I could probably find literally any mathematical ratio I want if I just run enough combinations.
Oh, absolutely. Zeising's methodology was deeply flawed, but, his confidence was very persuasive.
People love a confident expert.
They do, and his theories just went viral in the academic world. So then, in the 1870s, another psychologist, Gustav Fechner, attempted to prove Zeising right through an actual empirical study.
Okay, an actual study. How do you do that?
Well, Fechner showed participants 10 different rectangles and just asked them to choose their favorite one.
Just pick a rectangle.
Yep. And he reported that roughly 35% of people chose the golden rectangle, which is the one that has the exact proportions of 1.618.
Seriously, that's it.
That's it. And for well over a century, that specific experiment was cited in textbooks as hard scientific proof that humans possess this innate native preference for this specific geometry.
But wait, if Fechner's 1870s methodology was really that rudimentary, there must be modern attempts to replicate it, right? Like using more sophisticated psychological tools, you can't just base a whole century of architectural and artistic theory on a multiple-choice rectangle test?
You would think, but modern cognitive science has actually entirely dismantled it.
Tell me more.
This brings us to a really pivotal 2024 study. It was published in the journal Symmetry by researchers Stefan Steiger and Viren Swamy.
Oh, nice. Very recent.
Yes. They set out to determine if human beings truly harbor a deep subconscious preference for the golden ratio. But to do this, they didn't just ask people what they liked. They utilized an implicit association test, or IAT.
Okay, so for anyone who might not be familiar with that methodology, an IAT is designed to bypass our conscious biases.
Right, it gets under the hood.
Exactly. Instead of asking for your opinion, it measures your reaction times in milliseconds as you categorize different concepts on a computer screen.
It's super precise.
Yeah, so if your brain strongly associates two concepts, like, say, a specific image and the concept of goodness or beauty, you will press the sorting key fractions of a second faster than if the concepts contradict your internal beliefs. It tests the automatic software of your brain before you even have time to overthink it.
Beautifully explained. So Steger and Swamy presented participants with artistic photos where the main subject was aligned perfectly using the golden ratio. And they contrasted those with photos using just simple symmetry or totally alternative ratios.
And what were they looking for?
Well, if Zeising and Fechner were right, if this ratio is the universal biological standard of beauty, the IAT would definitively reveal an automatic, lightning-fast cognitive preference across the board.
Right, because it would be hardwired into us.
Exactly. But the results showed absolutely zero automatic, implicit preference for the golden ratio.
Zero. Wow, so if they found zero implicit preference, that just completely invalidates sizing's whole
It
premise.
really does. It means the objective formula for beauty doesn't actually exist in our subconscious at all.
So what did they find then? Why do people say they like it?
Well, what the researchers did find was highly revealing. Any explicit preference participants showed for the golden ratio, meaning when they were consciously asked to pick their favorite, strongly correlated with their prior art education.
No. So it's totally learned.
Exactly. It is a textbook example of the mere exposure effect. We don't prefer the golden ratio because it's like mathematically divine. We prefer it because Western culture, art schools, and media have just repeatedly exposed us to it and basically instructed us that it is the benchmark of good design.
It's learned cultural conditioning, not biological destiny.
Precise.
And that cultural conditioning explains so much. It explains why modern graphic designers and marketing teams are still so obsessed with it today. I mean, it explains that absurd Pepsi document.
Yep, the breathtaking document.
Right. And it also explains those viral diagrams of the Apple logo constructed out of all those golden ratio circles. You see those everywhere online.
Oh, those diagrams are wild, especially because Rob Yanoff, the designer who actually created the Apple logo in 1977, has explicitly stated that he drew the apple entirely freehand.
Freehand. There was no math involved at all.
None. He said he just added a bite mark so people wouldn't confuse the silhouette with the cherry.
That is so funny. And it's the same with the Twitter bird logo, right? It's constructed from standard circular arcs just so it scales cleanly on digital screens, but it has absolutely zero mathematical relationship to 1.618.
Right. We are constantly retrofitting the math onto successful designs just to make them seem profound.
Well, here's where it gets really interesting, though. Because if the golden ratio is basically a scam in art and logos, why do we constantly see it in nature?
Now, this is a crucial scientific pivot. Because while the golden ratio is undeniably a cultural myth in the realms of art and corporate branding, it actually possesses a very real, undeniable presence in nature.
Okay, tell me where.
Specifically, we see it in a branch of botany and physics known as phyllotaxis.
Phyllotaxis, which is the study of how leaves, seeds, and branches are arranged on a plant stem, right?
Exactly. If you examine the center of a sunflower, the seeds form these mesmerizing, sweeping spirals. And if you count the spirals going clockwise and then count the spirals going counterclockwise, you almost always end up with numbers like 34 and 55.
And if you check the bottom of a pine cone, you find spirals of 8 and 13.
Right. And those specific pairs of numbers are always adjacent numbers in the Fibonacci sequence.
Ah, Fibonacci.
Yes, the sequence that begins 1, 1, 2, 3, 5, 8, 13, 21, and so on, where each number is the sum of the two preceding ones.
Okay, tracking with you.
So as you move higher up that sequence, if you divide one number by the number immediately before it, say, 55 divided by 34, it converges precisely on the golden ratio, 1.618.
Wow.
And when this mathematical relationship is applied to a circle, it creates what is known as the golden angle, which is exactly 137.5 degrees.
Okay, so if plants are strictly adhering to this 137.5-degree angle to grow their leaves and, pack their seeds, it implies nature is actually utilizing this math for a specific purpose.
Yes, but based on everything we've discussed, it can't be because the plant is striving for some mystical standard of beauty.
Obviously not. It has to be functional.
It is entirely devoid of aesthetics. It is just raw mechanical physics. Researchers have modeled this extensively using something called the Keller-Siegel model.
What's that?
It's a mathematical system used to describe chemotaxis, basically the way biological organisms move in response to chemical signals.
Okay, so how does that apply to a leaf growing?
When a plant grows a new leaf, that new leaf emits a biochemical signal that physically repels the next leaf from growing too close to it.
Oh, that makes sense.
Yeah. The plant is operating under conflicting physical constraints. It needs to pack as many leaves or seeds as possible into a highly confined space, but it also absolutely must prevent them from overlapping so each leaf can capture maximum sunlight.
So it's fundamentally an energy minimization problem.
Exactly.
To synthesize this, it's remarkably similar to boarding a crowded subway car at rush hour.
That is a great way to think about it.
Right, because when you step onto a packed train,
Yeah.
people don't form perfect, rigid columns. Everyone naturally just, shuffles and pivots and repositions themselves to maximize their own elbow room while avoiding the people right next to them. You self-organize based on spatial pressure.
That is a perfect analogy for the biological mechanism. And physicists Stéphane Douady and Yves Coudert at Paris Diderot University proved this beautifully in a laboratory setting.
Oh, they actually simulated it.
They did, But they didn't use plants. They used magnetism.
Really? Magnetism.
Yeah, they created an experiment where they dropped magnetized drops of silicone oil into a magnetic field in the center of a dish. The drops naturally repelled one another.
So as they kept adding more oil drops into the center, the older drops were pushed outward by the magnetic repulsion of the new ones.
Exactly. And because the drops were confined to a radial space, a circle, they had to find the most efficient way to push away from each other without colliding.
And let me guess.
The pure spatial geometry of a circle dictates that rotating exactly 137.5 degrees the golden angle is the absolute most efficient way to distribute objects radially without them ever perfectly overlapping.
So the oil drops did what the plant seeds do.
Yes. The magnetic oil drops spontaneously organize themselves into the exact same Fibonacci spirals you see in a sunflower.
That is incredible. So the golden ratio isn't the goal of the plant at all. It's simply the inevitable physical byproduct of trying to pack things efficiently in a circular space.
Right. It's a functional solution for survival.
So the math is a description of physical efficiency, not some magical blueprint for beauty.
Precisely. Which really brings us back to the psychological question raised by mathematician Keith Devlin.
What does he say about it?
He asks, if this is just a botanical packing mechanism, why are humans so fiercely determined to force it onto ourselves?
And then what's the answer?
Devlin suggests that, as creatures genetically programmed to seek meaning, we are deeply, deeply uncomfortable with the subjective nature of aesthetics.
Subjectivity is messy.
It's messy, it's debatable, we want rules. We basically crave the ability to validate our personal tastes with mathematics because mathematics feels objective, unarguable, and safe.
That makes so much sense. Claiming a painting is beautiful is just a personal opinion. But claiming a painting is beautiful because it mathematically conforms to 1.618, well, that suddenly elevates your opinion to a scientific fact.
Exactly. It provides a massive security blanket for our egos.
But a security blanket can easily become a straitjacket. I mean, we take a debunked mathematical standard and start using it to judge actual human beings. The consequences have to move from just being theoretical to being actively harmful.
Oh, they do. And the medical field offers a really stark example of this harm.
Tell me about that.
So in the 1990s, an oral and maxillofacial surgeon named Stephen Marquardt developed something called the golden decagon mask.
The golden decagon mask. That sounds ominous.
It was. It was a highly complex geometric grid constructed entirely from the golden ratio, and it was aggressively promoted as the definitive objective template for the perfect human face.
Wait. Trying to create a mathematical biometric template for human beauty sounds eerily similar to the phrenology stuff we discussed earlier.
It really is. It totally assumes a monolithic standard of perfection.
Was it actually used, though?
It was incredibly influential. The mask was utilized in orthodontics, plastic surgery, and clinical facial analysis for years.
Oh, my God.
Yeah. However, in 2008, a comprehensive peer-reviewed analysis was conducted on Marquardt's mask to evaluate its claim of universal beauty. The researchers systematically applied the mask to a diverse global population.
And let me guess, the anatomical failure of the mask was staggering.
Completely staggering.
Where specifically did the mathematics fail to align with the anatomy?
Basically everywhere outside of one specific group. The grid completely failed to account for structural variations that are standard across massive portions of the human population.
Like what?
Well, it didn't accommodate the wider nasal bridges or varying cheekbone structures typical of sub-Saharan African faces. It completely failed to map onto the eye spacing and flatter facial profiles common in East Asian populations.
Wow.
And honestly, it didn't even accurately describe the facial structures of ordinary European populations.
Wait, if it failed across basically every major demographic, who was the mask actually modeling?
The analysis concluded that the golden decagon mask really only aligned with one extremely narrow demographic, masculinized white fashion models.
You're kidding.
No, that was the only phenotype that consistently fit the grid.
So, under the guise of objective mathematics, we were essentially pathologizing the facial structures of billions of people.
Right, and if we connect this to the bigger picture, this really highlights the profound danger of the whole Zeising myth. When we apply rigid mathematical templates to humanity, we aren't discovering some universal truth. We're taking a messy, incredibly diverse, dynamic world and forcefully cramming it into a completely arbitrary box.
We just disguise our cultural biases as unalterable mathematical laws.
Exactly. The golden ratio is a remarkable number in physics. It elegantly describes how sunflowers distribute their seeds, how pine cones grow, and how repulsive forces interact in radial spaces. But it is entirely unequipped to act as a judge of human physical worth.
I think that's a perfect place to land. So what does this all mean for you, the listener? Let's summarize the key insights from the research we've analyzed today. First, the enduring belief that the golden ratio is this universal aesthetic law governing art, design, and human beauty. It's largely a 150-year-old myth.
A very stubborn myth.
Very stubborn. It was catalyzed by an overly confident 19th century psychologist and is basically sustained by our brain's inherent desire to find recognizable patterns where none exist. We learn to prefer the ratio through cultural exposure, not some biological imperative.
And second, the true scientific marvel of 1.618 is really rooted in the physics of nature.
Right, the plants.
Yeah, plants utilize the golden angle not for aesthetic purposes, but as a brilliant functional mechanism to survive, grow, and pack seeds with maximum spatial efficiency through physical self-organization.
So we've spent a century and a half believing a completely debunked mathematical formula for beauty. And as we wrap up this deep dive, it leaves us with a critical, really forward-looking question to consider.
What's that?
Well, today, we are rapidly transitioning into an era dominated by AI-generated art, algorithmic video editing, and, those biometric facial filters on platforms like TikTok and Instagram.
Right, they're everywhere.
Exactly. And these algorithms don't just write themselves. They are coded by human beings who carry their own cultural biases. So if we aren't careful, are we at risk of accidentally coding Adolf Zeising's debunked golden ratio myth directly into the software of our future?
That is a scary thought.
It really is. Are we quietly enforcing a completely fabricated mathematical standard of perfection on a whole new generation, simply because it is easier for a computer algorithm to process a rigid geometric template than it is for it to comprehend the diverse, complex reality of human beauty?
The tools change, but the cognitive trap remains exactly the same.
Exactly. It is definitely something to seriously evaluate the next time an app automatically corrects the shape of your jawline or the width of your nose.
Well, thank you so much for joining us for this deep dive in the Deep Dive Lab. If you enjoyed uncovering the true science behind this historical mystery, please follow and subscribe for more fascinating science stories. Until next time, keep questioning the patterns you see, and we'll catch you on the next deep dive.